In this video, we are going to look into the magnitude and phase plots of the Fourier series, whose coefficients that are ak are expressed by this case equation. So in these coefficients, the DC value is set to 0. That is, whenever k is 0, so we would have a value of 0. And when k is not equal to 0, so we have this coefficients. So let us see the magnitude plot until the third harmonic. So we know that a naught is equal to 0, which is mentioned over here. Similarly, we can have an a1 for which we can set k equal to 1, and for that we would have a minus 3 by pi j, and then we have a cos of pi by 2 minus 1, right? And cos of pi by 2, this is actually 0. So hence we have a value which is a plus 3 by pi j. So this also indicates that the magnitude of a1, so this is simply 3 by pi. Similarly, the second harmonic a2, for which we have set the value of k equal to 2, so we are having the value of 3 by 2 pi j cos of pi minus 1, and cos of pi, this is minus 1, so hence the outcome would be 3 by pi j, that is a2 is again having a value of 3 by pi. So both a1 and a2 are equivalent. So as we mentioned, we're going until the third harmonic. So for a3 we have minus 3 by 3 pi j cos of 3 pi by 2 minus 1. Now cos of 3 pi by 2, this is actually 0. So hence we are having a value which is 1 by pi j, and that is the magnitude of this, that is a3 is simply 1 by pi. So therefore the magnitude plot with respect to omega, we have 0, omega naught, 2 omega naught, 3 omega naught. We are going until the third harmonic. So the magnitude plot, that is absolute value of ak. So at 0 we are having a value of 0. At a1 we are having a value of 3 by pi. So say this is that 3 by pi. At 2 omega naught, second harmonic, again we are having a value of 3 by pi, whereas at a3, that is the third harmonic, we are having a value of 1 by pi. Also note that this plot is basically an even function, so we would have the same, this repeated over here on the left side, so that is omega naught, that is minus omega naught minus 2 omega naught and minus 3 omega naught would have these values. So this is the magnitude plot of it. Now regarding the phase plot, for the phase plot we have phase, that is theta, or we can say the angle of ak. So this can be attributed by means of a function which is tan inverse the complex part of ak over the real part of ak. So for the phase plot, the angle, again we are checking ak at dc value, that is 0 frequency, omega naught, 2 omega naught, 3 omega naught, right? So at 0 we observe that the a naught is 0, right? So tan inverse of 0 is 0, so the phase is basically 0. For rest of the values, all of them are having a complex part, but there is no real part, so that means the real part is 0. So this means that this real part is 0. So if this part is 0, overall we have 10 inverse of infinity. So if we have 10 inverse of infinity, so for all of this we are having 10 inverse of infinity, which is simply pi by 2. So at the first harmonic we have a phase of pi by 2. Similarly, the second harmonic, again it is just complex value. So there the real part is 0. So if the real part is 0, again we have a pi by 2 here. And for third also it is again the same, pi by 2. Moreover, this phase plot is an odd function, so hence we are having minus omega naught, minus 2 omega naught, minus 3 omega naught. So for these values we are having a phase of minus pi by 2. So hence we have the phase plot and the magnitude plot.